I tell you, these things are so complicated. No, it's not the simplest thing. The most complicated things are really complicated. What I wanted to do, and I believe I finally got, I did it, and everything's, of course, working perfectly well according to it's what it seemed to be going on. But then you try certain things and a bunch of assertions would go off. Now here's something that I simply do not understand at all. The hell? Okay, well first let me explain. This notepad cube, okay, it's really slow to load up files. Much slower than Notepad, my rival. Previously, see, I have this great big file here. Let me install a prior version. Like this one, or 11. I may have fixed 11. Try 11. Not 11. 10. You saw that was pretty fast, right? Well, it wasn't fast like that a couple days or even this morning. What we're waiting for at the moment is nothing that the program is doing. We're waiting for the edit control to sort out the data that it's already been handed. Now let's put it in this one. So here's what things were like this morning. Come on. Okay. Now I believe it's currently on UTF-8, which is the slowest for me. It has to be, yeah, UTF-8. So you see, it's going to be a long time for this to show up. I'm going to, end up canceling all the time. Let me just see what the format is. Oh no, it's Unicode. Even Unicode is that slow. Okay. UTF-8's even slower. Alright. Now, that's one problem, that the slowness to load it up. The other problem was the one you just saw. With this faster version, the loading is almost instant. Getting the data into, and it's going directly into a local heap buffer, and then I'm just doing edit set handle equals somewhere. Set handle equals, and okay, now this is something I just introduced because of some assertions that were going on, and that's what I want to get to. But first, let me just show you again. So loading up the data. Now the data is in one of these H locals, this HMEM in fact. Well, this HMEM wiggles its way down into this struct from where I can do this. I want to do this through the structure because that clears out everything about that memory object. Now, I shouldn't say, as far as the code goes, this shouldn't be hlocal really. It should be mreal, declare one of those, and then pass that in or something like that. Whatever. Now, all this time, what's going on is nothing I can do to speed this part up. This is the edit control doing its thing. It's quite a bit faster without the recorder. And eventually it'll do it. It'll, place that text in there. Alright. Now, the way I've been doing this is I invented a new version of read text file yet again. I've already done a video on this, but I deleted it. Where's read text? Okay. Now I've split it up into two functions. This has the format of the old function, and this just calls this one using the normal realic. And so anybody that's using this function won't have to change. I don't have to change that code. But if I want to specify an allocator function, especially if I want to allocate into the local heap, as in this case, right, so that I don't have to make copy and then copy again into the edit control, I need this. Okay. Now what I want, my model was based on the idea of the realic function behaving in every way like the CRT realic function does. Okay, so there are occasions where I'll do something like, where is it? Here. If there's a buffer, then called realic buffer 0, and that for the regular realic would have the effect of freeing the buffer, right? Now that's not true of local realic, but that's okay. I made my own version of realic that uses local realic and changed the behavior to act like this. And working on that, first it was it's still a class. It was a class with basically only static member functions. So I didn't have to maintain anything, and I didn't think I had to maintain any data because of the following fact. What I thought was a fact anyway. Now here's realic. Previously, I was just making calls to this function. Now, if anyone can explain to me the logic behind this flag, then you get a gold medal or something. Okay, now reading this slowly. HMem is a handle to a local memory object to be reallocated. So local heap, sorry, not local heap, that's different. I'm calling it local heap because you get H locals and so on. But in fact, the phrase local heap refers to malloc, the memory that comes out of malloc. Okay, it's a handle returned by local alloc function. And these are known to be slow functions. Size of the new block, flags specify. If flag specifies modify, then this parameter is ignored. Okay. Otherwise, it doesn't specify modify. If it doesn't specify modify, right, then it can be one or more of the following great big long list of flags. This or this. lmem movable allocates fixed or movable memory depending on how the memory was originally allocated with local alloc. If local alloc was initially called as the movable flag, the return handle is a memory object that is a movable thing, and you have to call local lock to get a pointer out. Otherwise, if local alloc was called with lmem fixed, the return value is simply a pointer. It can be used as regular memory. Well, like, call me stupid, but obviously this is the one and everyone would use, right? Because then it's working exactly like realloc in the sense of, pass in a pointer to memory, give out a pointer to memory, and no calls to local lock. 0 init, okay, initializes the memory to 0, well, whatever. Big deal. Now, of course, that would be fine, but certainly in the end, what you want to pass back to our edit control is not a lmem fixed thing. You want something that's movable, right? That helps in keeping the memory from getting fragmented, and that makes sure that there's always enough memory available and you can always reallocate things. Well, that's not a problem because if you specify lmem modify in this function, okay, then u_bytes is ignored, and this parameter modifies the attributes of the memory object. Okay, so with modify, the flags parameter modifies the attributes of the memory object. Okay. Without it, then it's this thing I just went over. Okay. Now, besides the size, which attributes, other than movable or not, does one of these heap things have? I'm asking anybody watching this, and please type in a response if you can think of another attribute besides movable and size that one of these local heap or global heap memory objects has. I can't think of any others. So I assume, naturally, that the only possible use for this modified flag is to take what was originally a fixed memory thing and turn it back into a movable thing in the end, and then everything works out all kosher and great. Well, and there's nothing here to indicate otherwise, right? And I was going on that assumption, and the code's gone now, but before I passed the memory back to the edit control, wherever that was, here, I called realloc with modify and movable, change it to movable, and then unlock it, right? And then I pass in, well, first I put a dummy handle in the edit control, whatever, private data area, just, you know, or whatever, whatever happens to be there, I take it out, right? And forget about the please wait. And then I set the handle to this new movable thing and free off whatever was originally there, and everything's great. Or everything seemed to be working perfect. Well, I guess it was working perfectly, except then a bunch of assertions started going off. And the assertions were going off when I was doing things like search replace. And the assertions always said when I was trying to unlock a handle that the handle was already unlocked all the time. Right? Couldn't figure that out. Well, why? Why is it doing that? And well, that would occur. One way that could occur is if the handle to memory is not movable, in which case the lock count is always 0. The memory is always locked, and unlocking returns a failure because the thing's already unlocked. It's neither locked or unlocked. It's just its count is 0 in terms of locking, right? Well, then I looked online, and now I found this. I didn't find this originally on Microsoft's site. I found it somewhere else, and then I found it on Microsoft's site. Now this says CE, but it applies anywhere, I'm sure. Okay, this is the part I don't understand. Okay, if the modify flag is specified, this parameter modifies the attributes of the object, and uBytes is ignored. Otherwise, it controls allocation of the object, as we've seen. The following flag can be combined with the lmem modify flag, lmem movable. Okay, now that's what I was doing. However, you cannot combine the lmem movable with lmem modify flags to change a fixed memory object into a movable one. If you do, the function returns an error. But what is the point of saying modify and movable together, right? If you're not trying to change something from fixed to movable. Like, maybe I can change something from movable to fixed with this. If it does not specify modify any combination, well, that's where we already saw. So basically what it says is, if it starts out fixed, it remains fixed, and you can never change it from being fixed, ever. And the modify thing cannot be used to modify anything about it. It's just there to give you hope that maybe it's possible, but you cannot use it for that, for the only purpose you would ever want to use it for. Fair enough. So I went and rewrote the thing, and now this what I call mrealloc, this structure has members. Now I've got to call local lock. If I'd known at the beginning I could have started out this way and I wouldn't have had this problem. See, like, it was very hacky to begin with. Here I've got a pointer to, itself, and everything was static functions, and on construction I would set this global to, and I still do. Where else do you think I want it? I set the global pointer to this object equal to itself. Because what I need to pass into my read function is a reality. Nothing with this pointers, right? I didn't invent any other parameter to pass in. Which is okay, because I'm only ever dealing with reading one file at a time, and it's not that big a deal. So now to make this behave like reality, p void is a pointer to memory. It has to be a pointer to memory because the read function is going to write to it. Okay, now if that's null and the size is 0, don't do anything, because I found that if I call local realloc with null and 0, it gives me a valid pointer. I don't want that, so I'm null. If it's null and the size is positive, I want this to behave like malloc, right? Now I have something called expected size, and that's where I really boosted the speed. I reduced, instead of calling realloc on every byte, I call it gets called like once or twice max. Oops. Expected size begins a life as the size of the file, and we grow. If it's positive, it's not 0. The expected size, right? A size has been passed in here. But if I'm expecting a great big size, then now I have changed this to, instead of realloc, create and lock. So I do local alloc movable and then return local lock. And I would have known to do that before if it said that. Same thing here. If pointer passing is not null and size equals 0, it has to behave like free. Now I don't need to lock or unlock anything. In this case, local free will just wipe this out. And this just clears out there's only 2 data members within 0. Now we're still inside realloc. Otherwise, if the size happens to, now one of the great things about these local handles to memory things is you can find out how big they are at any time. Something strangely that doesn't exist with the local heap. It would, but it would be a debug only function. So anyway, look, I can get the size of how much I've got, and if the size requested is bigger than this current size, now this is, see the thing is, let's say that the file is ANSI file, right, and I've passed in as the expected size, the size of the file. But my buffer is in Unicode buffer, right? So it's really going to be twice the size, generally speaking, for ANSI or for UTF-8, approximately 2 times. So what I want to do is I want to double the size, but just multiplying by 2 is too close to being at the edge of, it might have to do another reality. So I just add 1/4 of size. So this is 2 plus 1/4. 2 is 8 quarters and 1 more quarter. And then now I'm saying set expected size to the new size. Why am I doing that? Oh, because I use that value here. I don't have to do that. I mean, I could just use new size here. In fact, I should do that. Because I might move that line, right? And that line doesn't, I might want to have it here, but it certainly shouldn't matter if I put it there, right? That shouldn't change the logic. Now, here was where all the assertions finally die. I have to unlock, because it has been locked, right? There's something called PV that was passed in. That's the locked thing. I have to unlock it, and I have to be maintaining this handle somewhere. So it has to be this struct. And then do the regular local realloc, movable, going to be help. Movable just maintains the movableness of the thing. This works even if it's locked, by the way. However, I don't know if the thing returned by this, right, whether it succeeds or not, is a valid pointer I can pass back. I want to call lock again. It's best to unlock, do the realloc. That may fail. If it fails, I should return no, and I should free the one that I've already got. If it succeeds, I should assign the new local heap pointer to this that I just got, and now return local lock. Otherwise, if none of those things are true, that is, the size isn't changing, I already have enough allocated, then what their PV is still valid, so I can just return it. So with those changes, and although it's difficult to understand how this turns into this, but this HMEM, no matter how this works, you'll see how it gets put in there. Method size. Where do I put it in? Getting the file size, setting the expected. It's still not. A reference to that variable is going to get passed into that struct somewhere. HMEM data. Okay, so here as a reference it's passed into here, so it's not obvious, but in fact realloc, that takes a pointer to void 0. Oh, but it's initially null, but this has no effect, thankfully. I better assert that because I gotta change it. This here should, all this stuff should be done earlier so I can see it where it's relevant. Now either it's going to go to that dialog which gets passed in a reference to a handle. As long as it's references, then okay. See? And this thing passes that same reference eventually to the loading thread. Well, that is the thread. There's the dialog whose constructor takes a reference. No, that's not the dialog. The dialog's constructor is down here. Here. Takes a reference, passes that same reference to the thread that does the loading, and so everything is everything. It's going to wind up into that struct because this will get called, which passes that same reference as a pointer to void to this function. Right? Now it's still not an actual pointer to void. But it gets passed into realloc, and how does that get turned into? Well, it's no. It's still no. Eventually, that realloc thing returns stuff, right? And the thing that it returns is assigned to this, right? This PV text buffer will eventually, at some point, either through here or all these things, will be assigned something that is returned by that static function of the reallocator struct. For instance, in UTF-8 case, where is that? Here. BV text buff is realloc of something, right? Initially this will be no, and eventually this thing, which is really a structure with members, will return its internal member, and that will be assigned to this thing, which will be used as an actual pointer. That's very complicated, the fact that that all works out. And it does. What have I got set here? I'll take, for instance, that huge file. Okay, it's a 90 meg file. Right? And running under debug with the recorder on, and all sorts of things to make it to slow it down. What did I change in here? Hopefully nothing significant. Normally I don't even see this part. It just zips by and I don't get a chance to see it. Now this is not behaving correctly. It should have allocated the entire, it should have doubled the size. Now this is a new thing I added, this please wait. This here will stay up until the edit control becomes responsive. And that's when you'll see the, the little bars here. And that's something I have no control over, but I can detect it. And it's usually faster than this with a, see, little thumb things showed up. So that means that now the edit control is actually doing something. It's receiving messages. It's not just working on sorting out the data, and it should show up pretty soon, visibly. At least you see these, right? And that lets you know something's happening. I don't know, how. I could also maybe somehow try and detect whether or not there's text visible. Well, I have no idea how to determine an estimate for how long. It's not that long. It's really when it's I'm going to change it as the worst case scenario. Change it to the worst case scenario. UTF-8 is the worst for me because I go through my logic's not very quick. I'm not using any given operating system functions. Even the saving's not that fast. It is 90 megs. Now the same thing will be quite a bit slower. But not that slow. Now remember, this is going directly into a local heap buffer. So after this is done, there's no copying of the data. And this memory has been allocated. All the reallocs that are being called, maybe with one exception, are not doing any allocation. I do trace it out actually, so you can check. Now it will go to the please wait. This is also a mode. This is another thread that's running this dialog. That's when my thread modeless dialog, which is invoked just after or just before switching the. You can see there's two windows. This one I can bring up, but not the other one. It should be a file manager. Okay. Now it's 20 megs before I use the other dialog, and after the reading. Alright, so where do I do that? It must be after calling read text. Oh. Read text. Oh yes, here we go. Please wait dialog. It's come in yet? Oh, it has. Believe it or not, the edit control is active at this point. It received a message. Because the way this thing works, the wait function. This is how this thing, it creates a thread. It's derived from this thing, which has an extra thread. Okay, there's a thread. The thread proc runs a message loop. Okay, now it's one message loop. But in order to see anything happen, I need to run another message loop, and that's what this wait does. This wait here sets up a second message loop in the thread that's calling it, which is the main thread, that retrieves and dispatches messages only to the edit control window, which is now there. And the reason I want that to happen is because what I do is I have one of these thread safe booleans, and I post a message to that edit control special message, the address of that thing, after 1 second has elapsed. Give some time. I don't want it to suddenly die. And then I switch to a second timer, and every two. Now this window proc is being pumped by the thread of the dialog. The other one, the thread proc message loop, not the wait one. The wait one is feeding messages to the edit control, and the edit control, luckily, I have hooked. So very complicated, isn't it? In here somewhere, there is the subclassing of the edit control. The edit control is subclass, and it has a thread proc somewhere. That's where I was. That's the frame window proc. Okay, here's the edit window proc, replacement window proc, and when I see that message, I just set that boolean thing to true, and when this thing sees that that's true, it kills the timer and doesn't do anything else. But in this thread, it's dispatching loops to the messages to the edit control. If it sees that that thing is not false, it breaks, it calls end dialog, which is a synchronous call, so that I know that that thread will be dead by the time I get to this line. The thread, no, sorry, I don't know that it's dead, and that's why I've got this here, loop, while the dialog is still active. Although maybe I don't need it. I think that is a synchronous, that end dialog is, I probably don't need this. Okay, I'll let it out. It still work. No crashing. Because end dialog, this function waits for at least 10 seconds for the thread to die. If being called from another thread, it just sits there and waits for at least 10 seconds. It might take more than 10 seconds, but I doubt it. And that's how you get, and that's all there is to getting one of these things nice and optimized. I found out a few more things about the user assist things, columns, and I realize now that I need to display both the canonical name and the process, because one of the ones I found out, one of the ones I discovered was this thing. That was one of those mystery keys, and that's just Explorer. So now I've got two Explorers on my thing, and that's no good. So this should be fine. When this thing disappears, the dialogue thread will have died. Or whatever, what you saw there. Following the weight. I don't need to further check if the dialogue's accurate. See, it's fine, perfectly fine. Yeah, so what I need is they're both long strings, so I thought maybe I could put another column in. I don't know. Some things don't have a canonical name. Or I could leave the canonical name and just put the icon of the program. That's an efficient way to demonstrate both things. See, that was pretty fast compared with what it was before. Okay. What it was before, it's night and day. Instead of 1,000 years, it's fast. It's fast like Notepad is fast. Okay, well, so that's all really complicated, and I'm sorry if I confused you or anything. But you might want to go through slowly and try to figure out what the heck I'm doing here with this, all these threads and allocating from the local heap and mimicking reality and all that stuff. In theory, it sounds easy enough to do, but in practice, it turned out to be a bit of a headache. See you. Oops.